like I said, really what we've been practicing with last week and also what we're going to do now today are skills that we can use to help us solve. That's ultimately what we're leading towards with logarithms, is to be able to solve anything that's trapped or any x that's inside the logarithm, be able to solve for that. So we rewrote them, evaluated them, and now we're going to talk about how we condense a log. So there are three properties that go along with logs. Essentially what it does is it translates whether or not you're adding two logs together, subtracting two logs together, or if there happens to be a number in front of the log. Others translate to something else with condension. So it's not a straight translation between the two different things. I'm actually going to cover it up so we just kind of do one at a time. Okay, so this is called the log of a product. The reason why that's called log of a product is if you have two logs that are being added together, we can actually translate, or we can condense those, and the addition translates to a multiplication, which is a little goofy, but the reason why that works is it's kind of stems from our exponential rules. Like when we multiplied an x times an x, we added their exponents together. So that's where this word comes from. So if you're adding two logarithms together, it's like you're adding exponents. So really what you're doing is you're multiplying. So I know, like I said, it's a little bit goofy. But again, whenever you see two logs added together, again, the bases have to be the same. So both of them are in the property, in the definition, are base b. So the way we can condense these two logarithms is by multiplying together what each log has. So I'm going to do a little mini example underneath it. So for instance, if we have log base 4 of 4 plus log base 4 of 10, okay, we can condense this into one logarithm. So we can do that. We're going to get rid of a log. So it's still going to be log base 4. So the base remains the same, but instead of having two separate logarithms, again, the addition translates to a multiplication. So log base 4 of 4 plus log base 4 of 10 will condense to log base 4 of 40. So you multiply those numbers together. Most of the time we have something other than numbers. Most of the time we have numbers and variables, a mixture of the two. But again, that's kind of a little mini example with just numbers. So like I said, the big goofy thing with the properties is that it's not a direct translation. It would make a lot of sense if addition translated to addition. But with logarithms, like I said, since it's based around exponents, it kind of stems from that rule that we use whenever we multiply x's together. Yeah, they're exponents. So whenever you add two logarithms together, what you can do to condense those is by multiplying the stuff that's with the log. So then our second one is called log of a quotient. And essentially, instead of adding your two logs together, you're subtracting the two logs. And so what that translates to is division. Again, so you have the same base. This only works if they are the same base, and if they're being subtracted together, what we can do is divide the symbols with the log. We did have an exponent rule like this. We don't use this one quite as often, but if you ever divided two x's, you can combine them by subtracting their exponents. It's like if you had x to the 5th over x squared, that becomes x to the 3rd, because you can subtract their exponents. Again, this stems from our exponent rule. So it's not a direct translation. So if you're subtracting two logarithms together, the way you can condense that subtraction translates to a division and stuff. So let's do a real quick mini example. So here we have log base 5 of 5 minus log base 5 of 60. Again, we don't have to leave those two logs separate. We can condense those. Again, it's still log base 5. So whatever the base of the logs remains, but instead of having two logarithms, you'll have one. And so then the subtraction translates into a division. So you have 5 divided by 60. a little mini example. Like I said, the majority of the time we'll have these mixture of numbers and variables, but I'm just doing quick mini examples with just numbers. Questions about the second property? Okay. We just have one other property that we can use, and that's if you have a coefficient in front of the log. So if you have a number in front, what that it's basically being multiplied by a number. What that translates to is this number in front of the log can become an exponent of whatever's inside the log. Okay, so that y translates to an exponent on x. And again, that stems from an exponential rule as well. Whenever we give an exponent, another exponent, we multiply them together. So this one, technically, we're multiplying a number to a log. So technically, we're multiplying a number to an exponent. So that number can become an exponent. So that's where that rule stems from. Like, it's not a direct translation, but all of it comes from those exponential rules. So let's just do a quick mini example. So for instance, if we have 2 log base 4 of 10, okay, the way we can use this rule to condense that is you can take this number that's in front, and where that translates to with the condension is it becomes an exponent on the number that's behind the log. So instead of 2 log base 4 of 10, we can make this log base 4 of 10 to the second power. Okay? Which in turn then we can make it log base 4 of 100. So that's how I can use my second condension rule. So our 3 rules, if you have 2 logs that are being added together, that translates to being able to condense them to 1 log, and you can multiply the stuff that was with the 2 logs originally. And we can actually do it with multiple logs. So if you add 3 logs together, you just multiply all 3 things you have together. If you have 5 logs, you can just multiply everything together. So it can be more than 2. In fact, most of the time we work with at least 3 logs that we're condensing. And then with the quotients, when you subtract the 2 logs, that translates to division. So again, we're reducing it down from 2 logs to 1, and by dividing the stuff that was with the logs. Again, it's not a direct translation. That's what you have to kind of get used to. So when you add 2 logs together, when you condense them, it translates to multiplication. We subtract 2 logs together. When you condense those, that translates to division. And then the other little rule is if you have a coefficient or a number in front of the log, where that when you condense that, what that becomes is an exponent on the thing that's behind the log. So if it's a number, we go ahead and solve that out, that exponent. So we could do 10 squared, so that's where I got 100. If it's a variable, just have to leave it as an exponent. Now the majority of the time, if you have multiple logs, we can actually do a mixture of all of these together. So very, very rarely are you going to get a condension where you're just using the product rule or you're just using the power rule. Most of the time, we kind of do a combination of at least 2 of them. A lot of times we combine the power rule with one of these other 2. Like I said, sometimes we might condense and we might be using all 3. Let's do some of my type examples. And the direction for this is condense. So whenever you're asked to condense, you're going to start with multiple logarithms. Any type of logarithm, any base. So we can use log base 3, we can use log base 10, we can use log base 5. We can use ln, because remember ln's natural log is just a special log for e, but that's also a logarithm. So you can use this any of these properties for any logarithm that we can think of. Okay, so here's how I always start when I condense. I actually look and see if I need to use the power rule first, because those are the things I'm going to take care of first. So when I know I need to use the power rule, is if you look in front of each log, there's a number. Okay? So that's what I take care of first before I do anything with the addition or subtraction that I have in the problem, because those numbers are going to translate into exponents. So I'm going to go ahead and do that condension before I do the rest of it. So that 2 is going to become an exponent on the 7, and that 5, and again, leave the subtraction, that's going to tell us something different, so it's just 5, is going to become my exponent on x. that first part of my condension, that log base 3 is going to now have 7 squared, which I'm going to solve that to 49 in a second. So anytime you have a number to an exponent, you can go ahead and solve that out. But on this next one, since it's an x, we just leave it x to the fifth. So on my next step, I'm going to switch that 7 squared to 49, but x has to stay to the fifth. So that's the first part of the condension. And I will say, once you get good at this, you can actually combine some steps. So if you want to do the changing of the exponents and then also the next part all together, like I said, once you kind of get the hang of the rules, you're more than welcome to do that. In fact, most of the time I can condense in one step just because I've done this a lot. But if it helps you go kind of step by step, that's what I'm going to do for my examples to show you where everything's going. So we translated the exponents. Now we're going to condense. So instead of having 2 separate log 3's, we're just going to have 1 log 3. And then everything else is going to go behind it. So usually I throw in some parentheses to show that, okay, now I'm going to put multiple things with this log because I only had 1 thing to start with. So when I have 2 logs that are being subtracted, using my rules, what does the subtraction translate to? Divide. Yep, so you're going to always take the first divided by the second. So that first is 7 squared, which I'm going to switch that to 49 right now. And we're going to divide that by the second, which is x to the fifth. So, like I said, usually once I'm doing the condension, if I'm putting multiple things inside of a log, I put my own parentheses to show that, okay, this started with 1 thing, now I'm condensing it into multiple. So now I have log base 3 of 49 over x to the fifth, and that is condensed. So when I had to use 2 of my rules, I used the power and the quotient. Questions on the first one? Real quick, there's supposed to be a colon here. Example 2. Oh, 2's not worth the ln. I just noticed that. So, when we condense, where are we going to start? Yep, the beginning power. So this ln doesn't have any number in front of it, so I don't have to worry about exponent there, no exponent there, but this 3, that's going to become an exponent of the thing that's behind it. Now if you notice, this ln already has multiple things, so that exponent is just going to go on everything. So this can now become y plus 2 to the third power. So this ln hasn't changed yet. This ln hasn't changed yet. That 3 is no longer there. This is now going to be ln of y plus 2 to the third power. Okay, everyone listening to me? You do this, I'll know you weren't listening to me. You cannot distribute an exponent, remember? Because whenever we had something squared, we had to take y plus 2 times y plus 2. So if you have something like this, that's actually you take y plus 2 times y plus 2 times y plus 2. Now, unless you really want to multiply that out 3 times, you certainly could, but I'm telling you, you can just leave it y plus 2 to the third power, okay? Because again, you can't distribute the exponent, because again, that exponent is telling you to take that thing times itself 3 times, which I'm not going to make you do, okay? So just leave it. Anytime you have something in parentheses to an exponent, just leave it. Even if it's a square, because we've done those a lot already, but anytime you have parentheses to an exponent, just leave it. There's no sense of multiplying that out. It really doesn't make our problem that much more simple. That makes sense? Okay, is everyone listening to that? Okay, so we translated the number in front to become an exponent. So now I'm just going to condense from left to right, because if you notice, now I have 3 ln's, and my ultimate goal is to get it down so I can just have 1 ln. So I just condensed from left to right, and I'm going to do it in 2 steps. Like I said, once you get the hang of it, once you get good at it, you can probably do it all at once. Well, I said, for our examples today together, I'm going to do it step by step so you can see where all of it is translating to. So I'm just going to condense these first 2 ln's. So this one's going to stay as is for right now, but I'm going to take these 2 ln's and make it just 1 ln. Now they have an addition in between it. What does that translate to when I condense it? Multiplication, yep. So you're going to say x times 5, which I'm just going to make it 5x because that's typically how we write that. Questions on the first convention, or second part, I guess?
So we just multiplied the x and 5.
Yep. And so if you can actually multiply them together like we did on my little mini example with 4 times 10, make it 40. And this one we don't know what x is, we just have to leave it at 5x. So now we're going to condense one more time, because again, we've taken it from 3 logarithms to 2, and now we want to take it from 2 to 1. So our ultimate goal, our ultimate final answer should just have one ln. Okay? And so we're going to put ln and all the stuff behind it. So I'm going to put my own parentheses. So that way you can see that the stuff is inside the ln, so that's why I add those parentheses in there. So now we're subtracting those two things. What does the subtraction translate to? Division. Yep, so it always goes in order. First divided by second. So the 5x is going to go on top. Actually, I'm going to move it off to the side because that's pretty long on the page. So the 5x is going to go on top, and then the y plus 3 cubed is going to go on the bottom. So now I've taken it from 3 ln's, took it down to 2, now it's down to 1, and we have that condensed. Questions about the second one? So we'll just do two little more examples, and then we do have a little X that I did on this paper. Alright. For this next example, I'm going to do a little bit of my shorthand. That way you don't have to rewrite it 8 times sometimes. So again, we're starting with multiple logarithms, and our goal is to condense it down into 1. For this example, just real quick, when we don't see a base on a log, what base is it? 10. Yep, so these are all like log base 10. You do not have to write in the 10, but again, that's just trying to reinforce that if you don't see a base on the log, it's a common log, it's base 10. So this first one, again, we have to get rid of the exponents. We have the, or numbers in front, so those are going to condense into exponents. And on this one, I just have the one exponent. Here's a little bit of shorthand that I do. Instead of having to rewrite it, just so I can put that 2, where's that 2 going to go? Yeah, it's going to be my exponent x. So I don't have to rewrite that whole thing. So I can just get exponent of 2 to x. Here's what I do. I just cross it out and make that an exponent. Is that okay with everybody? So you can do that. Otherwise, you can rewrite it. That's fine. Like I said, so that way you're not rewriting it 3 times. We actually can just rewrite it twice. Or like I said, if you really get good at this, you can just do it in one step. So I'm still going to do it step by step. So I'm going to condense my first 2 logarithms together, and then I'm going to condense that third one with it. So we're just focused on these 2. So these 2 logs, they're being added together. So what does that translate to when I condense? Multiplication. So I'm just going to have 1 log. And then the log is going to be x plus 2 times x squared minus log. I left it like this for now, but what do you suppose we can do with that x squared? Distribute. So I am going to distribute that in a second, but again, just to kind of show you that if we condensed it to multiplication, I left it out, but I will eventually change that to x to the third plus 2x squared on my next step, okay? So now I'm down from 3 logs to 2, so I'm going to condense it down to just 1 log. So these 2 logs have a subtraction in between it. So what does that translate to? Division. Yeah, so we're going to take all of this, which I'm going to distribute that now, and it's going to be divided by 5. So I have x to the third plus 2x squared. So am I distributing over 5? And so I've condensed it from 3 logs down into 1, which is my goal. So this is condensed. Question on second. What's different about the last one?
Logs and parentheses.
There's some parentheses in there. Okay. Suppose that makes a difference?
Yeah.
Yes, it does. Okay. Typically what parentheses tell you to do?
Solve all of that before.
Yep. Do that first. So still in this, even though we're really not computing anything, we're just taking logs and making it down into 1. It's still telling us that we need to condense these first, because usually you condense from left to right like I have been doing. So if there's ever time where I want you to condense the second 2 first before you condense that first log, you'll see parentheses around it. So really that's all that's telling you to do is to condense these 2 things first and then pull in that first one. Okay? Still, what do I need to take care of first? Yep, if there's a number in front. So no number in front, no number in front, number in front. So where's this 9 gonna go? Yep, it's gonna become my exponent on x. So again, because I see those last 2 logs in parentheses, that's telling me to condense that first. So what does that addition translate to? Multiplication. Yep. So this first log base 4 is going to hang out there in front. So it'll be 2x. Still have a minus, but we'll just have 1 log base 4 behind it. And we're going to take this 5x plus 1 times x to the 9th. Which what are we going to end up doing with x to the 9th? We're going to distribute that. Well, and you can do that right away if you want. I leave it separate to kind of show you where everything's going. So that addition translated to multiplication. And so now we're going to, we've condensed it from 3 to 2. So our last thing is we need to get it from 2 logs to 1 log base 4. So what does the subtraction translate to? Division, yeah. So log base 4, big parenthesis. So the 2x is going to go on top because that comes first. And then it's going to be divided by, we'll distribute that x to the 9th. So we have 5x to the 10, and then plus x to the, and then we can say it like that. Questions about the convention? It's a little weird because it's not a direct translation, because addition translates to multiplication, subtraction translates to division, numbers in front translate to exponents. It's a little goofy about all the rules, but again, it all stems from our exponent rules of old. So, other questions everybody has? So we do have a little exit ticket. I just didn't get it attached to your note paper, so you can just use your own half sheet or whole sheet of paper. I want you to do 2 quick ones, and then I'll hand out the assignment, which does come from the book, because that's why there's a page number in the note sheet. Okay. So 2 quick conventions for the little exit ticket. Like, so just get a half sheet or whole sheet of paper and work on these 2, and then I'll hand out